Yeah, resign again. Again resign. Resign. Yes. Yeah. So let us start session. Yes, last class. Yes, ATM day 2. So last class day 2. Yes, about all that Java history discussed. So why got this much of popularity discussed? So what is present question of Java, feature of Java discussed here? So about Java discussed. Yes, here. So what is Java? Yes, let us review yesterday's class. Just to first out, just only 2 minutes. Just 2 minutes. Let us review. Java is an OOP language. OOP stands for Object-Oriented Programming Language. OOP stands for Object-Oriented Programming Language. JDK, Java Development Kit. JDK stands for Java Development Kit. JDK from Sunsoft. Yes, it is now with Oracle Corporation. It is now with Oracle Corporation. JDK 1.0. First version of Java released in the year 1995. First version of Java released in the year 1995. Okay. So first version released with these features. Yes, today's is a topic. So this is topic for today. Okay, yes, about Java features. Today we'll be discussing about Java features, all the Java features. Okay. So today topic is about Java features. Okay, fine. Next JDK 1.1. Yes, in the year 1996. There's in point 1.1. The JDK divided into 3 editions. Later, next JDK 1.2, 1.3, like different versions released here. JDK 1.5. Yes, major changes. Main important version here. Yes, cordless Tiger version. Cordless Tiger version released in the year 2004. So many features were added. Yes, even fourth one, Java effects. Java effects also added. Java effects also added in this version, JDK 1.5. Okay, finally, JDK divided into 4 editions. Java Standard Edition, Java Enterprise Edition, Java Mobile Edition, and Java Effects. Yes, all these 4 editions. Right. Finally, Java, totally 4 editions. First one, Java Standard Edition. Java Standard Edition. Okay. Yes. So this is Java technology. So next, Enterprise Edition is a application development. Application development. All the frameworks comes in this category. All the frameworks. Okay. Yes, mobile edition and effects not in use. Okay. Next, these are the Java frameworks. Struts. Yes, outdated. Spring and Hibernate framework. Hadoop and Spark frameworks, Spring Boot and microservices. Okay, right? Yes. So here this is Spring and Hibernate frameworks. Yes, for internet-based applications and also for ERP application development using here. Next, Hadoop and Spark for the big data to handle big data challenges. Okay. Yeah, this is called as big data. This range of data, terabytes, petabytes, zettabytes. These things are big data. Main challenge data storage and data processing. Okay. So here with the Java, you can develop internet-based applications, ERP applications, and big data apps. Okay. So what is framework? Yes, it's ready-made one, ready to use. Yes, it contains all predefined classes. Okay, every task there is a predefined class. Okay. Yes, using predefined classes, we can build the projects. Okay, so about framework. Yes, advantages. We can reduce the codes, time of project development, reducing project cost, also reducing quality products. So all these topics yesterday completed. Yesterday completed. Yesterday all the history completed. All the history completed. All this history completed. Okay. Yes. Today, day 3. Today about day 3. Day 3. Today day 3. Yes, about these features. Let us start Java features. Yes, day 3. Yes, today topic is about this topic. Java features. JDK 1.0 released with below features. JDK 1.0 released with below features. First one, independent of platform. Next one, portability. Next one, OOP language. Next one, scalability. Next one, security. JDK 1.0 released with below features. First one, independent of platform. Next one, portability. Next one, OOP language. Next one, scalability and security. So these are the features, initial features of Java. These are the initial features of Java. These are the initial features. Okay. Yes. See guys, to understand all these initial features, yes, you must get some basics knowledge, software basics. So before going to these features here, we'll discuss some basics. Like basics like OS. What is OS? Operating system. So operating system. Yes, operating system. OS basics. Yes, like OS basics. How OS behaving? See, when Java application is running, when Java program is running, how OS is behaving. That OS behavior. That OS behavior. Okay. Yes, OS behavior. Operating systems. Okay. Yes, OS behavior. When you're running C program or C++, Java, and all of these things. So how that OS is behaving. See, independent of platform. Here, platform is OS. So you must have some idea about OS. Otherwise, you can't understand this one. So OS basics. Next, yes, about yes interpreter. About interpreter and compiler. About interpreter and compiler knowledge. About interpreter and compiler. Next, about exe file. About exe file and dot class file. About exe file and dot class file. About exe file and dot class file. Okay, about exe file knowledge and dot class file knowledge. About OS. Next, about interpreter and compiler. Next, about exe file dot class file. So next, about low level languages, and high level languages, low level languages, low level languages, and high level languages, low level languages and high level languages. Okay. Yes, if you have all this knowledge, if you have all of this knowledge here, then easy to understand about these features. Easy to understand about these features. Okay, if you know all of these things here, then easy to understand these features. Okay, so before going to these features here, let us start with basics. I'm starting with basics. Starting with basics. See, starting with basics. Starting with basics. Starting with basics. Okay, starting with basics. Yes, from the scratch, right from the scratch, starting here. Right from the scratch, software basics. Right from the scratch. Okay, so before going to Java, there are some basics. One second. Before Java, some basics knowledge here. If you have that basics knowledge here, then easy to understand Java. See basics like a system software, application software. Next about OS. Okay, next yes about front ends, back ends. language and packages. Next, low level language, high level languages. Okay, so these things here. So these things, next, interpreter and compiler. Okay, yes, how Java is working. Yes, once you have this knowledge, then easy to understand Java. So let us start with basics here. I'm starting with basics. Okay, starting from the scratch, starting from basics here. Okay, so even non-IT background guys also understand these basics here. Anyone can understand easily here. Okay, starting with basics. Okay, see, first of all, computer well. Yes, computer well. Yes, computer well. First of all, computer well. Yes, computer well. Yes, computer well. See, computer well basically two categories. First one, hardware. Second one, software. Hardware and software. Hardware and software. So hardware and software. So what is hardware? What is software? Yeah, hardware, yes, well known for you. Just like a monitor, keyboards, hard disk, RAM memory, motherboards, all the hardware components. Yeah, these hardware components we can touch. We can touch all the hardware components. Yes, we can touch all the hardware components. But this is not our part. Yes, ours is software. Ours is software. So let us start with software. Let us start with software. Let us start with software here. See software. What is software? You see in software, everything is a program. Everything is a program. Everything is a program. Yes, it's a collection of programs. It's a collection. It's a collection. It's a collection of programs. It's a collection of programs. Software is a collection of programs. In software, everything is program. So what is a software means? It's a collection of programs. It's a collection of programs. Everything is program in software. Everything is program software. Okay. Yeah, the software. Software basically two categories. Software, yes, basically two categories. Software basically two categories. Software basically two categories. Two categories. First one, yes, system software. Second one, application software. System software, next application software. System software, next application software. System software, next application software. System software. So what is system software? System software, yes, it interacts with hardware components. It interacts with hardware components. Hardware components. Yes, system software. It interacts with hardware components. System software. It interacts with hardware components. It interacts with hardware components. Okay. Examples. Yes. Operating systems. Yes. Operating systems and device drivers. Operating systems and device drivers comes in this category. System software. It interacts with hardware components. System software. It interacts with hardware components. Okay, system software. See, software basically two categories. System software, next application software. System software, next application software. System software. It interacts with hardware components. Example, operating systems and device drivers. Okay, next, application software. What is application software? What is application software? Yes, application software. See, for the purpose of application development. For the purpose of application development. Application software. This is for the purpose of application development. Apps. See, in our daily life, we are using many applications. Many applications. Tell me some applications here, guys. Yes, some examples of applications. See, application software. for the purpose of application development. For the purpose of application development, applications. Some examples. Applications, some examples. Yes, anyone? Yes, in our daily life using many applications. Yes, can you tell me some applications in our daily life using many applications? Many applications.
WhatsApp.
Yeah, WhatsApp. WhatsApp. Yes, you can
Internet.
chat box. You can ping in chat box. Chat box available. Okay. See WhatsApp. See WhatsApp. Next Facebook. Okay, Twitter. Okay, next Flipkart. 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 Yes, next. Yes, banking applications, banking apps, banking apps. Okay, next. Online trading applications, online online trading, online trading apps. Okay, these kind of applications, right? Yes, many applications we are using, many internet-based applications we are using. Okay, every day, day-to-day life. Right? These applications, how to develop this kind of applications here? How can you develop this kind of applications here? For this, yes, application software. This kind of applications, yes, these kind of applications we can develop using application software. This kind of applications we can develop using application software. So application software for the purpose of application development. So by example for the application software, Java is the best example. Java is a mostly used application software. Java is a mostly used application software. Java, .NET, yes, Python. Python is application software. Yes, next Hadoop is application software. Yeah, databases are application softwares. Like this many things. C language and C++. These are application softwares. Okay, fine. See here, in software we are using many technologies. In software we are using many technologies. More than 100 technologies we are using here. In software more than 100 technologies. In software more than 100 technologies we are using, right? So which is exactly application software? Okay, see, in software we are using some languages. See, some languages we are using here. Languages using. Okay, some tools using. Next, and some package using the tools and packages, languages like Java, Python, C++, HTML, like this many languages we are using. Tools like data warehousing tools, testing tools, next AWS tools, DevOps tools, like this various tools we are using. Right, okay. Next, many tools we are using. Packages like MS Office, ERP package, like this many packages. Many things we are using, right? So what is exactly application software? Which is exactly application software? See here, system software. It interacts with hardware components. System software, it interacts with hardware components. System software, it interacts with hardware components. Okay, see OS. Only OS can interact with hardware, others cannot. Of course, here device drivers. See here device drivers part of OS. Device drivers are part of operating system. Device drivers, device drivers are part of OS only. Device drivers are part of operating system only. Device drivers are part of OS only. Okay, right? Yes, only OS can interact with hardware components. Only OS can interact with hardware components. Only operating interact with hardware components. Okay, so except OS, all are application softwares. See, except operating systems, all are application softwares. All are application softwares. All are application softwares. All are application software. That's clear. Except OS. Except operating systems. All are application softwares except OS. Except operating systems, all are application softwares. Okay. Yes, now let us say about OS. What is OS? Yes, let us say about OS here. About OS. See here, you guys, running notes is not necessary. It's there in document here. See today topic. Software is a collection of programs. Software basically two categories. Okay, like system software and application software. System software, it interacts with hardware components. It interacts with hardware components. Application software for the purpose of application development. Application software for the purpose of application development. Okay, example C, C++, Java, .NET, ERP and other packages. See, except OS, except applications, all are application softwares. Except OS, except all are application softwares, except OS. Same thing it's in document here. Same thing prepared exact in document here. So here running notes is not necessary. Running notes is not necessary. Just you follow document here. Just you follow the document here. Running notes is not necessary. Running notes is not necessary. Okay. Follow document here. Try to understand the classes enough. Try to understand classes enough. Okay. Now let us say about OS here. So what is OS? Yes, about OS. Yes, about OS. So what is OS? About OS. Yes, here. See some question before discussing about OS. Some question for you guys. Some question for you guys. Question. Yes, can we run any program without OS? Can we run any program without OS? Can we run any program without OS? Anyone guys? Yes, can we run any program without OS? Can we run any program without OS? Simple question, simple question. Can we run any program without OS? Very simple question. Can we run any program without OS? Yes. Yes, sir. Okay. Can we run any program without OS? Answer is no. No, we can't. We can't. We can't. OS required. So OS required. So without OS, we can't run any programs. Compulsory OS required. Compulsory OS required. If no OS, no computer. No OS, no computer. Okay. Yes. See here, except. See, except bias. Except bias. Except bias to run. Yes, to run. Except bias. Except bias to run all programs OS required. All programs to run all programs OS required. OS required. Okay, except bias. See, except bias. See, except bias. Except bias. Except bias to run all programs OS required here. Except bias. What is bias here? What is bias? Bias stands for yes, basic, yes, input and output system. Basic input output system. Basic input output system here. Bias stands for just basic input output system here. Input and output system. So bias is a hardware. Yes, bias. So bias is a yes hardware. Bias is a yes. Bias is a hardware program. Bias is a hardware program. Bias is a hardware program. Okay, it's a chip level program. Yes, it is a chip level program. It's a chip level. It's a chip level. It's a chip level program. It's a chip level program. Okay, bias is a chip level. Yes, 1 second. Chip level. Okay. So bias is a chip level. Bias chip. Okay, this is a chip level program here. So there is a bias chip. Yes, in your system motherboard. In motherboard, there is a bias chip. Bias chip contains bias program. Basic system, basic input output system here. So bias stands for basic input and output system. Bias stands for basic input output system here. Correct? Basic input output system here. Yes, bias is a hardware program. It's a chip level program. Okay, right? See, once you power on your computer, here. So first of all, power goes to bias chip. Then bias program starts. So what's the role of this bias here? Bias is responsible. Bias is responsible. Bias is responsible. Bias is responsible to load. Yes, bias is responsible to boot operating system. To boot operating system. Look up to boot operating system. Bias is responsible to boot the operating system. Okay, so what is bias? What's the role of bias is here? So bias is responsible to boot operating system here. So what is booting here? What is booting? See, booting. Yes, booting is a process. Booting is a process of loading OS from yes hard disk to RAM memory, hard disk to RAM memory, hard disk to RAM memory. Okay, booting is a process. Booting is a process of loading OS from hard disk to RAM memory. That's it. Okay, see here. Can we run any program without OS? No, we can't run. 1 second. Okay, 1 second. Yes, without OS we cannot run except BIOS. See, BIOS is a hardware program, it's not a software program. It's a hardware. BIOS is a hardware level program. So except BIOS to run all programs OS required. So BIOS stands for Basic Input and Output System. BIOS stands for Basic Input and Output System. So BIOS is a hardware program. So BIOS is a hardware program. Yes, it's a chip level program. Chip level program. BIOS chip. Okay. In motherboard, this is a BIOS chip. Yes, even let me show that BIOS chip. Yes, BIOS image. See that BIOS image. So this is BIOS. This is BIOS chip. BIOS. This contains BIOS program. So before going to start OS, first of all, BIOS starts. Once you power on your computer, first of all, BIOS starts. That the BIOS program is responsible to booting operating system. So what is booting? Booting is a process. Booting is a process of loading OS from hard disk to RAM memory. So booting is a process. Booting is a process of loading OS from hard disk to RAM memory. Booting is a process. Booting is a process of loading OS from the hard disk to RAM memory. Okay, yes. See, once we started, your system is ready. Once booting is done, once booting is over, system is ready. Okay, system is ready like this. Now here OS is ready, right? So once booting is over, now OS is ready. Now where this OS is running? So currently this OS is running RAM memory. So OS always running in the RAM memory. Everything happens in RAM memory. So OS running in the RAM memory. Now this OS is responsible to take your request here. This OS is responsible to take request and processing that request here. Taking your request and processing that request. So this OS is responsible. This OS is responsible to take your request and process that request. Process that request. Okay, right? Yes. Now OS. How OS is working? About OS. So what is operating system? Yes. Let us see about OS. What is operating system? What is operating? What is operating system? What is operating system? Let us see about OS here. OS. Let us see about OS here. What is operating system? See, operating system is like this. See, hardware, on top of hardware, operating system running. See here in your computer, there is a hardware. On top of hardware, OS is running. See, on top of OS, every program running like C program. Okay, C++. Okay, yes, Java program. Okay, yes, maybe Python scripting. All are running on top of OS. Even Hadoop also running on top of OS. Okay, Hadoop support database also on top of OS. So everything, even MS Office also OS requires. So these all are running on top of OS only. Yes, maybe some languages, some tools, or some packages, all are running on top of OS. Without OS, these programs cannot run. So every program, all the programs running on top of OS, all of the programs running on top of OS. So OS giving platform, it's giving platform to run all the programs. These are application softwares. All 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 these are application softwares. These are application softwares. Okay, these are application softwares. All these are application software. These are running on top of OS. These application softwares running on top of OS. These application softwares running on top of OS. So OS just it's giving platform. OS just it's giving platform. OS just it's giving platform. On top of it, all the programs running here. So OS acting like a platform. So what is OS? What is OS? Simple answer. What is OS? Means simple answer. Yes, it's a platform. It's a platform. It's a platform. It's a platform. What is OS? It's a platform. Yes, where we can run all the application softwares, all the application softwares, all the application softwares, all the application software. So what is OS? It's a platform. OS it's a platform. OS it's a platform. It's a platform where we can run all the application software. So OS it's a platform. It's a platform where we can run all the application software. So all application software running on top of OS only. Everything without OS, no program running here. Everything on top of OS. Maybe some languages, maybe some tools, maybe some packages. Even to run the MS Office also OS required. To run the MS Office, even for MS Office also OS required. Okay, right? See, OS not only platform here. See, operating system not only platform here. Suppose, for example, C++ these programs generating some output. So generating some output. So output of these programs simply goes to OS. Output of these programs goes to OS here, right? Yes, and then transfer to output device. Okay. Output of these programs simply goes to OS. Output of all the programs simply goes to OS, right? And then transfer to output device. Suppose reading from the keyboard. So keyboard data simply goes to OS. Keyboard data goes to OS here. Yes, OS to these programs. Okay. Output of all the programs first of all delivered to OS and then transfer to output device. Suppose reading from the keyboard hardware. Keyboard data first of all transfer to OS and then transfer to these programs. So between application software and hardware there is a OS. So between this application software and hardware there is a OS like a mediator. Exactly you can see the interface. It's an interface. So OS is an interface. OS is an interface between application software and hardware components. Okay, it's an interface. OS is an interface. It's an interface between application software and hardware components. So next, yes, it's an interface. It's an interface between application software. Software is an application. Yes, between application software and hardware components. See, it's an interface. It is an interface. We is acting like an interface. Interface between application software and hardware components. Application softwares and hardware components. Okay, fine. Hardware components. Okay, hardware components. Okay, so ways. Yes, what is ways? Means simple answer is a platform. It's a platform. See here. Yes, Java is an independent platform, right? Platform means ways here. Java is independent of platform, is independent of ways. Yes, how Java made us independent platform? Next topic we'll discuss which. How Java made us independent platform? It's next topic. So next topic we'll discuss. Wait, let us finish these basics. Once basics are finished, we'll go to the independent platform Java features here. Okay. Yes. So here, so what is OS means? It's a platform. It's a platform. On top of it, everything is running. Not only platform, acting as an interface between application software and hardware components. Okay. See here, application software application software data delivered to OS and then transport output device. Yes, suppose reading from the keyboard. Yes, keyboard data first of all goes to OS to these programs. That's it. So acting like an interface. It's an interface. That's it here. Next, one more thing here. In OS is a library. In OS there is a library. That library contains input output functions. Yes, input output functions means C language functions. C language functions. See, OS developed in C language. OS developed in C language. See, like OS means like Windows OS. Windows in C language. Linux in C language. Unix in C language. Almost all, every OS, Unix, Linux, Windows, Mac OS, Solaris, next HP Unix, like this different operations. All these operations developed in C language. C language. So OS contains some library. That library contains all input output functions. Library is a collection of input and output functions. Library is a collection of input output functions here to perform IO operations. Library to perform IO operations. Okay. So in OS there is a library. Okay, every OS there is a library. So using this library, it can communicate between application software and hardware components. Every OS has its own library. Every OS has its own library to communicate between application software and hardware components. Okay, see, every OS has, yes, has its own, its own library. Every OS has its own library to communicate. Yes, to communicate. Yes, to communicate between application software and hardware components. Every OS has its own library to communicate between application software and hardware components. Hardware components. So every OS has its own library. Every OS has its own library to communicate between application software and hardware components. That's it. So next, one more thing here. One more important point here in Java perspective. Some important point here. Java perspective, some important point. See, here these programs, C program, or C++, Java, Python, these programs, all these programs, first of all links with OS library. Linking with OS library, then communicates with the hardware components. Linking with OS library. Yes, it has to link it. Every program has to link with OS library before going to start execution. First of all, linking with the OS library. Yes, all these programs linking with OS library. These programs linking with OS library, then communicates with the hardware. Okay, that has to link. Every program has to link. Okay, so every program has to link with OS library. Yes, before going to run. One second. See, every program has to link with OS library. Every program has to link with OS library before going to run here. Get that link, maybe statical linking or dynamical linking. Statical linking and dynamical linking. The topic tomorrow. Tomorrow I'll explain here. Tomorrow I'll explain about statical linking and dynamic. Tomorrow we are going to enter into actual Java. So that time we'll discuss. Okay, today all the basics here. Tomorrow I'll explain about Java starting. Yes, in the topic I'll explain about statical linking and dynamical linking. Okay, so every program has to link with OS library before going to run it here. That may be statical linking or dynamical linking. That's it here. Okay, about statically, dynamically. Tomorrow topic with Java I'll explain. So this is about OS. That introduction is enough. So this is about OS introduction. Okay, right? Yes. 1 second. See, same points explain document here. See this. About OS. It's a platform where we can run all the application softwares. Where we can run, yes, all the application softwares. Okay, it's an interface between a hardware and application software. Same that 4 points explained here. Same thing. Hardware on top of it, OS on top of it, application software. These 3 layers. Same thing. Yes, here explained here. Okay, next. Yes, 1 second. Let me add this point also. Yes, about OS. Yes. So what is an operating system? What is an operating system? What is an operating system? So for this answer is these points here. So this is about OS. So this is about OS. Okay, fine. See here. Yes, in software, this system software, next application software. Okay. Yes, OS comes under system software. OS is system software. So what is Java? What is Java? Java is an application software. Java is an application software. Java is an application software. Now let us move to application software. Yes, about application software. Application software. Yes, in application software, there is a front end and back end. There is a front end and back end here. Front end, back end. So what is front end? What is back end here? Front end, back end. Let us see. Front end, back end. One second. Here, one second. Front end, back end. See. So this is go to training app form, right? First name, last name, email address, phone number, right? These things here. So the details, right? Is a registration form. Registration form, right? Just filling form. We are filling form and submitting. Yeah, this is called as front end. This is called as front end. So this front end taking data. So front end, this is taking data. So the front end taking data and storing some location. Yes, your first name, last name, email address, phone number, taking all the details can storing some location. That location is called as backend. Backend is for the data storage. Front end is to collect the data. Front end is to collecting data. Front end is to collect the data. So front end, it collects data from users. So what is front end? Front end, it interacts with end users. Front end interacts with end users. Front end interacts with end users. It collects data. It collects data from the end user. It collects data from end user. It collects data from end user and stores in the backend. Stores in the backend. Okay. Yes, same thing here. The document here. Application software. Yes, Java is the application software. So that's the reason move to application software. In application software, again, 2 categories, front end and back end. Java comes on which category? Which category is it, front end or back end? Now let us see here. So back end. So back end. So these are easy to store and maintain data. So the back end, easy to store and maintain data. Example, databases and files. HDFS means Hadoop distributed file system. Hadoop distributed file system. So backend is to store the data. Backend is to store and maintain. Backend is to store and maintain data. So what is front end here? Front end. So these are to interact with end users and collecting data from end users stores in the backend, right? So front end collecting data from end users and storing to backend. Okay. So it's a front end. So this is front end, right? So behind of this one is a JSP. It's a JSP here. So fill the form. Once you fill, submit, register. Behind of this form, Java program running. JSP means Java server pages. It's a Java program. Java program taking this data. Java program taking this data. Java program is taking data and storing into backend here. So if Java comes out front end here, Java program taking data from this form. Yes, after filling form, submit. Once you submitted the Java program behind the form, this is Java program. The Java program taking data, and stores into backend here, storing into backend. So Java is a Java taking data from us. So it's a front end. So Java is a front end. So Java comes on the front end. Okay, now let us move to front end. Our topic is now front end. See, 1 second. See software. Okay, system software and application software. Java is a application software. So that's the reason move to application software. So application software, here they say front end, back end. Java comes under front end. So that's the reason moving to front end now. Front end. In front end, language and packages. So what is package? Package is ready-made one, ready to use. No coding, without writing any coding. In package, coding is not necessary. In package, coding is not necessary. In package, coding is not necessary here. It's ready-made one, ready to use. Ready-made one, ready to use. So package is ready-made one, ready to use. Okay, MS Office, for example, MS Office package. So next ERP package like Oracle ERP, SAP ERP, they are ERP package, things Tally, accounting. So they are the packages. Packages are ready to use, no coding, without any coding. So coding is not necessary. Programming is not necessary. In packages, programming is not necessary. Directly finish. See MS Office, no programming, right? Directly finish MS Office. Okay, open MS Office, as open a Word, then prepare document, open Excel, prepare some records. Like this, that's it here. So no coding. Even Tally ERP also. Even Tally accounting package also, coding not necessary here. No coding. So without any coding, without with any coding, can is that here? Without any coding, can is that here? Without any coding, coding is not necessary. Coding is not necessary. Okay. See, when come to language here, we should write the coding, means programming. Okay, programmer has to write the coding here. Okay, languages. In language, everything is code. It's a programming. Programming. Yes, what is Java? Java is a language. Java comes under languages. Java comes under languages. Now let us move to languages. Yes, about languages. What is a language? See here. Yes, languages. Yes. What is a language? Simple question. What is language here? What is language? See, in our daily life, yes, we are just using different language, right? Depends on person facing, depends on person facing using different languages. Why? Like see, using some English, maybe Hindi, different language we're using here. Why? Communication purpose. Communication, just language, just it's a media of communication. Language is a media of communication between two persons. Okay. Yes, now come to software. Software languages. So what are the languages in the software here? Software languages. Software languages. Software languages. See in software here, in software, yes, computer understanding some language. Computer, yes, understandable. Computer, understandable. Computer, yes, understandable language. Computer, understandable language. This computer understandable language. Next one, user understandable language. User understandable, computer understandable, and user understandable language. User understandable language. Okay. So software languages. Software languages. So first one, computer understandable language. Next one, user understandable language. Yes, computer understandable language. Next, user understandable language. Okay. See here. So for example, C programming. C programming. See the C programming. Yes, looking like English language, right? It's a user understandable language. Looking like English language, it's a user understandable language. It's user understandable. User understandable. Suppose Java program. Java program. For example, Java program. Let us take some Java program. See, looking like English language. C program looks like English language. Java program looks like English language. Python looks like English language. So these are called as user understandable language. Okay, C++, Java, Python. Yes, all the user understandable languages. Okay, right? Yes, software. Yes, computer understandable languages. And next, user understandable language. So what is computer understandable language? See, computer understandable language. Computer understandable language, it depends. Depends on generation of computers. Generation of computers. Depends on generation of computers. Depends on generation of computers. So how many generation of computers? Yes, guys. Some question of 5. Some question for you guys. How many generation of computers? How many Yes, generation of computers. How many generation of computers? How many generation of computers? How many generation of computers? Anyone idea? See, computer understandable language depends on generation of computers. How many generation of computers? How many generation of computers? Anyone idea? How many generations? Yeah, 5 generations. Good. It's a 5 generations. 5 generations. 5 generations. It's a 5 generations. It's a 5 generations. It's a yes, 5 generations. Okay. Yes, first gen. First gen. What is first generation computer? Yes. There are 5 generation of computers. First generation. First generation. Yes. Vacuum tubes. Yes. First generation vacuum tubes. First generation, yes, vacuum tubes. Vacuum tube based. First initially computer, vacuum tubes based. So second generation transistor based, transistor based. First generation vacuum tubes, second generation transistor based. Next, what is third generation computer? Third generation. Yes, it's IC based, IC based computers, IC based integrated circuits. Okay, so first generation, second generation, third generation, IC based. Okay, next fourth generation. Yes, it's a processor based. This is present generation. Present generation. It's a present generation. Next, fifth gen is a feature generation. Yes, what is fifth generation? Yes, now presently we are using processor based. Fifth generation in future means maybe 2 or 3 years coming to the market. I think 2025 coming to markets. So what is fifth generation computer? What is a fifth generation computer? Yes, it's a AA based. It's a AA based computer. It's a AA based computer. Yes, AA based. Okay, totally 5 generations. Now presently processor based computer. So presently it's a fourth gen. It's a processor based computer. So presently this present generation. Okay. See what is processor based understandable language? Processor based, processor based, processor based, understandable, understandable, understandable language. Yes, understandable language is binary code. It's a binary code. It's a binary code. Processor based understandable language is binary codes. Binary code is like zeros ones format. Processor based understandable language. Processor based understandable language is it's a binary codes. So binary code like a zeros ones format here. Okay, zeros ones understandable. Yes, zeros ones format. Okay, it's a system understandable language. Yes, it's a system is processor here. It's a system understandable language. Understandable language. Here system means processor. System means processor. System means it's a processor. It's a processor. It's a processor. It's a processor. See what is A based understandable language? See, processor based understandable language is a binary code in the form binary code here. Zeros ones formats. Zeros ones formats. So what is A based understandable language? Yes, A based computer understandable language. A based computer understandable language. So what is A based computer understandable language? Yes, A based computer understandable language here. Yes, any idea? What is A based understandable language? A based computer understandable language. Any idea? A based artificial intelligence. Artificial intelligence. Yes, is English language. It's English language. English language. Yes, it can understand English here. AI-based computer can understand English. Okay, AI-based computer can understand English. In future, that AI-based tools, everything is coming AI-based tools. The tools can understand English directly. If he's saying some English, that can understand simply here. So AI-based computer understand the language here, English. English, it can understand our English here. So once AI-based come to the market here, things becomes easy. Okay. Yes, our works we can finish within short time. Very fast, quick. Yes, once AI-based computers come to the market here, yes, things becomes easy here. Okay, 1 second. Yes, everything becomes easy. Everything becomes automation. Everything becomes automation here. Yes, yes, here our work becomes easy. Within short time finish. Within short time we can finish our works. Okay, fine. Okay, yes, fine. Yes, so these are different generation of language, different generation of language. So present generation is processor based, processor based. It's a present generation, processor based. It's a present generation. It's a present generation. Correct. So it's a computer understandable language. Yes, Julius Funds format. This is called as low level language. This is called as low level language. That user understandable English called as high level language. High level language. So software languages are two categories. See, software languages are two categories. Two categories. Two categories. Software languages are two categories. Two categories. First one, yes, low level. Low level. First one, low level languages. First one, low level languages. First one, low level languages. Second one, high level languages. Second one, high level. Second one, high level languages. Low level and high level languages. That's it here. Okay. So software languages are two categories. First one, low level languages. Second one, high level languages. Low level languages. Low level languages. Yes, it's a system understandable language. Low level language. Yes, it's a system understandable. It's a system understandable language. A system understandable language. Okay, here system means processor. Yes, system means. Yes, system means processor. Yes, system means it's a processor. It's a processor. Okay, it's a processor understandable language. It's a processor. It's a processor understandable. Processor understandable language. It's a processor understandable language. It's a processor understandable language. Yes, it is a. Yes, it is a processor. It is a processor understandable language. It is a processor understandable language. Okay, processor understandable language. Okay. Yes, it is in the form of binary codes. Yes, it is. It is in the form of. It is in the form of binary codes. It is in the form of binary codes. Binary codes. So binary codes. Binary code is like binary code is a zero response format. Binary code is zero response format. Yes, it is called as machine language. 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 Binary codes. Binary code zero response formats. Yes, it is called as machine language. It is called as machine language. Okay. Yes, low level language. It's a system understandable language. System is a processor. Processors like we have 8085 and yes, 8085 and 8086. Now currently we are using 8086. Currently we are using 8086, 8085 and 8086. Currently before 90s 8085. From 90s onwards 8086, 8086. Presently 8086 here. Okay, fine. Okay. Yes, it's a processor understandable language. Yes, it is in the form of binary codes. Binary code is like this, zero response format. See, once you enter into Java, how that binary code is generating. How that binary code is generating, I'll explain very clearly. Once enter into Java, I'll explain about binary code. How that binary code generating, yes, we'll discuss in Java. Okay. Yes, it is called as machine language. Machine means computer. Processor. Machine means processor. Yes, it is called as machine language. Okay. So about low level language. Next, high level languages. Yes, about high level languages. About high level languages. About high level languages. High level languages. High level. Yes, it is user understandable. It is user understandable. Understandable. It's user understandable language. Yes, high level language. It's a user understandable language. Okay. Yes, it is like a. It's like English language. It's like English language. It's like English language. It's like English language. Okay, high level language. It's a user understandable 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 language. Okay. Yes, it is like English language. Yes, it is very easy to understand here. It is very easy to understand. Very easy to understand. Very easy to understand here. Okay, very easy to understand here. Very easy to understand. See, example of high level language. Java is a high level language. C is a high level language. C++ high level language. Next, Python high level language. There are high level language. HTML is high level language like this. High level language. Yes, looks like English language. Easy to understand these things here. Okay. So high level languages. High level languages. It's a user understandable language. It is like English language. It's very easy to understand here. Examples. There are examples of high level language. Yes, some question for you guys. Some question. Which is first high level language? Which is first high level language? Yes, which is first high level language? Which is first high level language? Anyone idea? Yes. Which is first high level language? Which is first high level language? Which is first generated high level language? Which is first high level language? Which is first high level language? C language. C language. C language is a first high level language. C language. C language. C language is a first generated high level language. First generated high level language. High level language. High level language. Yes. Yes. C is a first generated high level language. High level language. Correct? Yes. First high level language developed by whom? C language developed by whom? Who has developed C language? C language is a first high level language. C language is a first high level language developed by whom? Who has developed C language? Anyone idea? Who has developed C language? Who has developed C language? By Dennis Ritchie. By Dennis Ritchie. By Dennis Ritchie. By Dennis Ritchie. Dennis Ritchie has developed this by Dennis Ritchie. By developed by Dennis Ritchie. Dennis Ritchie. Yes, in the year 1972. C is a first high level language. Okay, fine. See here. So these are high level language programs here, like Java is a high level language program, like English language. Now this program has to convert into binary code. Java program, suppose for example C program. For example C program. Suppose C program, also English language, looking like English language. Yeah, these programs have to convert into binary codes. All these programs have to convert into binary code here. All these programs have to, these high level language programs, C program, or C++, Java, Python, these programs have to convert into binary code. All these programs have to convert into binary code here. So who will convert here? Yes, every high level language program. Okay, see every high level, every high level language program, every high level language program has to convert into binary codes. Every high level language program has to convert into binary code. High level language to binary code. Who will convert it? Which one will convert here? Which one will convert from high level language to binary code? Just anyone idea? Every high level language program has to convert into binary code. Then final execution. Now which one will convert from high level language to binary code? Someone required to convert. Which one will convert here? Yes. Yes, either compiler or interpreter. Either interpreter or compiler. Okay, interpreter or compiler. Okay, here interpreter. See, interpreter. Yes, interpreter, interpreter, interpreter or compiler. Interpreter or compiler. Interpreter or compiler. Converts from, yes, high level language. From high level language. High level language. Okay, interpreter or compiler converts from high level language. Okay, high level language. See, interpreter or compiler converts from high level language. From high level language to binary code. Binary code. Binary code. So interpreter or compiler. So interpreter or compiler, either interpreter or compiler converts from high level language to binary code. So what is interpreter? What is compiler? See, both are converting from high level language to binary code, but there's a difference. There's a difference here. So many differences are there in interpreter and compiler. Okay, yes. See, today topic, till now what I discussed here. Let us review today topic here. It's there in document very clearly. Yeah, this document for you only. I'll share this document for you. Okay, today I'll give the drive access. Okay, see, introduction. Today introduction. Yes, software, system software, next application software. Okay, next about OS, all these points. So what are we discussed? All these points test here. So next, yes, Java is a application software. See, the way introducing it is Java. How I am introducing it is Java. See here. So Java is a software. Yes, in that, yes, system software, application software. Java comes under system application software. Java is application software. So that's the reason move to application software. In application software, front end, back end. There's a front end, back end, front end, back end, front end, back end. So front end, back end. Okay, Java is a front end. So moving to front end. Yes, in front end, languages and packages. Language and package. Java is a language. So moving to language. Language low level and high level language. Java is high level language. Yes, about languages. See this. Languages. Yes, generation of computers. So what are discussed today here? Okay, all this. Software language, two categories, low level, high level language. About low level language explained here. Yes, about high level language explained here. Yes, which is first developed high level language, C language, by the Dennis Ritchie in the year 1972. Yes, examples of high level language, these things here. Okay, so every high level language program has to convert into binary code. Who will convert here? Yes, high level language to binary code. Yes, either interpreter or compiler converts from high level language to binary code. Yes, up to this is discussed today. Yeah, this today topic I'll share in the group. Okay, I'll share it. Okay, so next about interpreter and compiler. Next topic is about interpreter compiler. Yes, it will take almost 45 minutes class. Interpreter and compiler. Yeah, this topic tomorrow will continue. Yes, about interpreter and compiler. Okay. Yes, Fortran is also high level language. Fortran, Basic, Pascal, COBOL, all are high level language. Those are high level languages. Okay. Yes, interpreter and compiler. Difference between interpreter and compiler. This topic tomorrow will continue. Yes, yes, it will take minimum 45 minutes. Today we can't with a break at the middle. Okay. Yes, still we have only 10 minutes to finish our time. 10 minutes. Within 10 minutes I can't finish. So tomorrow we'll continue about interpreter and compiler. Yeah, that's all for today. Any doubts? Yes, guys, any doubts? Yes, guys, any doubts?
Actually, no doubts. I already emailed you. I was in 9:15 a.m. IST
Yeah, you
class.
can come. You can come for. I know that.
Okay.
Okay.
Do
Yes,
I
you
need to contact?
can. Yeah, I
Do I
will
need
add
to?
to it. No, I will add it.
Okay.
Okay.
Thank you.
Yeah. So that's all for today. Yes, tomorrow also same. Saturday tomorrow. Even Saturday same link. Same link tomorrow. No change in link here. Okay. Yeah, that's all. So thank you guys. See you tomorrow.